Yeah. Hello students. So in our today's video, we would be covering a very interesting topic of mathematics, that is factorization. Yes, when it comes to high school studies or be it your class 11, 12 studies of mathematics, factorization is a very interesting and important topic. Yes, with a bit of tips, tricks, and the way you get the questions, illusions created. Sometimes it may sound a little tricky or it may look a little tricky, but it's not that difficult. So if you have challenges understanding factorization, yes, you have hit the right spot. Pick up your pen and paper and let's get started understanding factorization in mathematics. Okay, so let's understand one thing, that in mathematics there are many reverse operations or converse operations we study, right? So as a kid we started understanding additions. Once we knew numbers, right, then we started understanding addition. Okay, and we understood that when we add two numbers 2 and 3, we get a different number called 5. Okay, and obviously after some time we started understanding the reverse or the converse function of that, which we call as subtraction. And you know it pretty well what subtraction is. So say if I subtract 2 from 5, I'll get 3, or if I subtract 3 from 5, I'll get 2, things of that nature, right? Similarly, in mathematics, we have studied your mathematical functions and operations like multiplications and division. So first we studied multiplication, which was pretty easier or relatively easier for us. And then we studied, the reverse function of it, which is division. And we obviously had, at least as a learner or as a beginner, we would have wondered, oh, why this reverse function is there, and that may have sound a little overwhelming, right? So similarly, if you see any function for that matter in mathematics, there are, I mean, for most of the mathematical operation, we also study the reverse function of that. So why am I talking about, functions and the reverse or converse function so elaborately today? The answer is, when we are talking about factorization, is factorization a direct function of something or is it a reverse function of something? And the answer is yes, factorization is also a reverse function of your multiplication. How? Let's try to understand. Okay, so we know when we multiply two numbers, right? So say, let's take the same two numbers. Okay, if I multiply 2 with 3, I get 6, right? So I have multiplied two numbers and I'm getting a new number 6. So in mathematics, obviously we say that 6 is a product of, so we can say that 6 is a product of 2 and 3, right? Similarly, if I ask you, 6 is a product of 2 and 3, great. But what are 2 and 3 of 6? So the answer would be 2 and 3 are factors. 2 and 3 are factors of 6. Okay, so if we want to understand this in a bit of Hindi, then we can say factorization is nothing but उत्पादीकरण, right? तो जैसे हम दो नंबर 2 एंड 3 को जब मल्टीप्लाई करते हैं अपने को 6 मिलता है, वैसे ही 6 का 6 में अपन क्या करेंगे, तो अपने को 2 और 3 मिलेगा. सो हम बोलते हैं कि 2 एंड 3 6 के उत्पाद यानी कि फैक्टर्स हैं, और इस क्रिया को हम उत्पादीकरण बोलते हैं, और दिस प्रोसेस is called as factorization in mathematics. So whenever you are getting a problem in an exam, that okay, factorize this, that means they want you, see, 6, when it is expressed in terms of multiplication of multiple things, okay? So whenever a number or a expression is expressed as multiplication of multiple things, then those individual things are called factors of the product. Similarly, just to understand, so this was with numbers, it was very easy. So let us understand in place of these two numbers, if I would have had two, what you said, polynomial expressions, suppose I would have had x plus 3 in place of 2, and suppose in place of 3, I would have had, suppose, your x plus 1. Then what would have been the multiplication or, the product of these two? So very simple. We know we can open the bracket, and obviously by using our expansion principles, it would be first term x into x plus 1 plus sign, then 3 into again x plus 1. So it will be x into x is x squared, x into 1 is plus x, plus sign, 3 into x is 3x, 3 into 1 is plus 3. So we can say this is nothing but x squared plus 4x plus 3. So if you see, this expression is the product of this and this. I repeat, this entire expression is the product of this and this, because obviously by multiplying these two things we have got this. So obviously this is product of these two. Similarly, can I say that this and this are factors of this expression? So that's why throughout factorization, what we would see, we would be, in our problem, we would see that an expression is given, okay, in terms of, addition and subtraction of multiple, obviously algebraic expressions. And then what we would try to arrive at would be, we would try to arrive at multiplication of multiple, your polynomials, such that degree of your unknown term, that is x, we would ensure that it's 1 in all the cases. So that is where we would understand that we have fully factorized this expression. Okay, so now obviously, if this is given, arriving at this could be a little tricky, and that is the subject matter of factorization. And let's see how we can deal that in mathematics. So let's get started. And as I said you, obviously factorization is an inverse process of multiplication. So we would try to understand this as, the inverse function, so that our concept will be clear. We would not end up just mugging up things. Okay, so let's see. Okay, so if two terms, right? So we know if we are multiplying a plus b with a minus b, what do we get? We get a into, now I'm just directly writing the formula because we already know this. So this is nothing but a squared minus b squared, right? So in an expression, so if multiplying these two, we are getting this. So can I say that a plus b and a minus b will be two different factors of a square minus b square, which means if my expression is expressed as difference of squares, right? If my expression is in the format of difference of square, a square minus b square, I can factorize that as a plus b into a minus b. Okay, we'll look into problems to understand, but let us first understand the theory part. Okay, first one. Second, if my problem is a whole square of something, a plus b whole square, or I can say this is nothing but a plus b into another a plus b, right? So we know the formula for this is nothing but a squared plus 2ab plus b squared. So what are we getting? If my expression is in the form of a squared plus 2ab plus b squared, then I can factorize that as a plus b whole square, or it's a multiplication of 2a plus b. How? We'll again see. Okay. So this we say perfect square. Perfect square. Because obviously it's a whole square, right? So one term or one expression is multiplied two times. Okay. Third one, similarly, we can have a minus b whole square. So that is nothing but a minus b into a minus b, and the formula is a squared minus 2ab plus b squared. So again, what we are getting? If my expression can be expressed in terms of a squared minus 2ab plus b squared, then I can factorize that as a minus b whole squared. And this is also called a perfect square, right? So today we will concentrate on these three forms, and there is one more which is even more primitive to this. That is, that is where we will take the we'll remove the common terms. Okay, so we will concentrate on these four forms today. So right now I'm writing these four. Apart from that, we have two other things. We will look into your four terms expression, and we will look into your quadratic quadratic expressions, and we will do middle term splitting here. Middle term splitting. So these two things would be subject matter of my next lecture. So I'm not explaining this in detail in this lecture. And obviously in this lecture, we will be concentrating on these three forms. Okay. First one, difference of square. So we will look into that. Next, perfect square, and one which I have not written here, and that is even more primitive. So I will say, your that will be form zero. That is nothing but reduce or remove any common factor. Okay, so we will go into them one by one, and we will see. Okay, so if you want your brain to work as an algorithm, then the moment you get a question on factorization in your exam, do this as your first step. Remove any common factor that you find in an expression. Okay, and then look for any of these. Then look for if your expression can be expressed as a square minus b square, difference of square, then we would say, or then we will factorize that as a plus b and a minus b. Okay? If it can be expressed as a square plus 2ab plus b square, very good. That means it is a plus b whole square. Or if it's a square minus 2ab plus b square, then it will be a minus b whole square. Sometimes one mistake students do, that this last term is b square. If in the expression it's coming as a square plus 2ab minus b square, or a square minus 2a minus b square, don't jump into a plus b whole square or a minus b whole square, obviously, right? So let's do one thing. Let's do some practice problems, and obviously we would be able to understand all this theory that we have studied here by doing some practice problems. So let's go and get started with our practice problems, and we will start with your type 0 or type 1. So if I say this as, say, your type 1, so let's do some practice problems related to type 1, that is removing any common factors from the expression. Okay, so say if my expression is x squared plus 12x, okay, and I want to fully factorize this, okay. So obviously in these two terms, what is the common term? The highest common term is x. So if I take x as common, then it gets reduced to this one. Now will be x plus 12x by x is nothing but 12. So obviously I'll say that x squared plus 12x is nothing but x into x plus 12. Now you see in this expression, the highest power of x is 1. For this term also, the highest power of x is 1. So which means obviously my expression is now fully factorized. Fully factorized. So you see here in the problem, one expression was given, and then what did I do? I removed any common factor. So what was the common term or common factor? X. So I took x as common, and then I am finding x into x plus 12. So obviously now the highest degree of x is 1 in all the terms, right? Or in all the expressions. So obviously I'll say that, and it is expressed as multiplication. So obviously my expression is now fully factorized, right? Sometimes in exam, if they ask you fully factorize, this is what you should do. Sometimes they may ask, find the value of x, find the value of x using factorization method. Okay, so if they ask you to find out the value of x using factorization method, and if it is given x squared plus 12x equal to 0, okay, then obviously your answer will be x. So these all remain same. So this much equals to 0, which means from here, if multiplication of two terms is 0, then there are only two possibilities. Either this term is 0 or this other term is 0, right? So obviously it will be either your x equal to 0. So if x equal to 0, obviously you got one value of x, okay? And what is the other value? Or x plus 12 equal to 0, or x equals to minus 12. So this is one value of x, this is another value, and obviously we know that if the degree of an equation is n, there could be n number of possible values of the root. So here in this equation, the degree of the equation was 2, or the maximum power of x was 2, and we got two values of x. One is 0, one is minus 2. So obviously that also satisfies our understanding, or basic principles of mathematics, and that's correct, right? So this is how we would factorize by removing any common factor. Okay, let's do one thing. Let's see one or two more examples related to removing common factor, so that it becomes, very easy for us. So let's go into one more quick practice problem, and that is minus 36 x squared plus 6x plus 6x, right? So if you see here, in these two terms, I can take 6x as common, right? And if I want to fully factorize it, the first step says remove any common factor, right? So I take 6x common, and obviously now this will be minus 6x plus 1, okay? Or I can, after that, I can just, beautify this a bit. So I'll say 6x common, 1 minus 6x. So this is the answer. So I have taken the common factor as common, and obviously this is how I would arrive at the, what you say, factorization of it. Similarly, if any value of this expression is given, and if you are asked to solve for that, then you can use the same thing which we did earlier. So if they would have given this much equal to 0, then obviously what you would have done is this equals to 0, or this much equal to 0. So obviously, if product of two things is 0, either this will be 0 or this will be 0. So we'll do the same thing. Either 6x equal to 0, which means x equal to 0, or 1 minus 6x equal to 0, or 6x equal to 1, or x is 1 by 6. So two values, x equal to 0, x equal to 1 by 6. Because the highest power of x is 2, or the degree of this equation is 2. So it's possible to get two values of x, and we got x equal to 0, x equal to 1 by 6. So the key here is you should keep a tab that in the exam or in the question paper, is it asking you to fully factorize it, or is it asking you to solve it? Okay, so fully factorize, if you express only up to this much, it's correct. If it is given this equation equals to 0, then obviously you need to find out the values of x. Okay, so many times in your physics you may be required to finding out the value of the variable, or in mathematics, you will be needed. So that is where factorization becomes very, very handy. Okay, so let's look into one more interesting example, and then we'll jump into the next pattern into factorization. Okay, so next example is 3ab 3a 3ab minus 6b, and the reason I have chosen this one is, don't be prejudiced that it would be always in terms of either x or y, right? So you can also get a expression like this: 3ab minus 6b. Okay, so if it is 3ab minus 6b, then obviously what would be the highest common factor? It would be 3b. So if you take 3b common, a minus 6. So that is it. So that's the answer. So if it has asked you to fully factorize it, 3ab minus 6b will be equal to 3b into a minus 6. Term 1 into term 2, maximum degree of variables is 1. So obviously this is fully factorized. Okay, so we have got our answer. Now, after completing this first, pattern of problems, let us move into the second pattern. And the second pattern was, we said, after removing the common factor, we would try to see if our expression can be expressed in terms of a squared minus b squared, or we call it as difference of squares pattern. And if it is in difference of square pattern, then we factorize it as a plus b into a minus b. So let's look into a couple of practice problems. Okay, so say my given problem is x squared minus 81. Okay, and it is asked to fully factorize this, right? So to fully factorize this, obviously, if you see the first term and second term, they appear to be square of two different things, and there's a minus sign in between. And remember, whenever you are solving difference of square, there will be two terms in the equation. Okay, so x squared minus 81. So that I can write as, first term can be written as square of x minus second term. What is the square root of 81? That is 9. So 9 squared. A squared minus b squared. So what is the value of a here? So x equal to a, and 9, this one, equal to b, right? So we know if it is a squared minus b squared, I can write a plus b into a minus b, which is nothing but a here is x. So x plus b is 9, a plus b into a minus b. So this would be my answer, right? So if I want to fully factorize difference of square, I would express both the terms as square of something, right? And obviously, once I have expressed a square minus b square, I can factorize it as a plus b into a minus b. And why? Because we know that in our expansion, product of a plus b and a minus b is a square minus b square. So obviously, as a reverse function, a plus b and a minus b would be factors of a square minus b square. Okay, so pretty easy. So now let's move on to one more problem and let's see. Okay, so we would solve one couple of more problems so that we get the heck of it. Okay, all right, it's got erased a square minus b square format. So next one we'll try to solve is 8x squared minus 9. 8x squared minus 9. And the reason why I have chosen this is, if you see here, first term does not look like a perfect square, right? Because had it been 4x squared, I could have written square of 2x. Had it been 9x squared, I could have written, 3x squared. But even if it is not a perfect square, that's still fine. We have studied radicals and surds, so far in mathematics. So I can say that this is nothing but, can I say root over 8 square into x square minus 3 square, because 8 is nothing but square root of 8 square, right? Similarly, x square is nothing but square of x. Okay. Now we know from our exponential functions, x to the power a into y to the power a is nothing but xy whole to the power a. So obviously I can write. So obviously I can write this part as root over 8, okay, into x. So don't, but be careful, don't, put the radical sign like this, because it's not square root of x. So x is still out of the square root sign, okay? So root over of 8 into x square minus 3 square. So obviously this is your a, this is your b. So now you can write a plus b into a minus b. Very simple. So a is root over 8x. Again, ensure that the radical sign does not go over x, plus 3 into root 8x minus 3. Okay. And if you want to do more practice, in bracket you can write as a square minus b square equals to a plus b into a minus b. So if you keep doing this, then obviously it would be very easy to for you to remember the formula. And many times, just to share one of my experience that I see people doing is, so whenever a lot of folks in IT industry they do coding, many times, in a review they get a common review comment that, hey, why your comments are missing. And I personally believe that as a student, as they never had a practice of writing the reason, they have done a step, but why they have done, as they never got into the habit of writing it. So obviously when someone grows as a IT professional and start doing coding, many times we see in IT industry that people write code, but they do not write, what you say, the comments, and then they need someone else to write the comments for them. So obviously that's not a happy scenario. But anyways, we don't want to get much into that. But what I would recommend you as a teacher is, when you're writing a step, at least for the first few problems, write the reason, so that you get used to with the formula. You may not find it difficult to mug up the formula, because you have written it 10 times while doing the problem, so it becomes very easy. Okay, let's solve one more problem on this, and we will know it little better. Okay, so what did you understand in this problem? That in the a square minus b square format, any of that term can also be a radical. I mean, sorry, it may be a surd as well. So it need not always be a fully square term. Okay. Now let's look into this one. 9x fourth minus 16x squared. Okay, 9x fourth minus 16x squared. And the reason why I have chosen this one is, if you see here, here we don't have anything to the power 2 directly. So if I want, I can still write it as 3x whole squared to the power 2, and this one can still. So suppose one student does like this, right? That he or she does. This is nothing but 3x squared to the power 2 minus, this is nothing but 4x to the power 2. Okay, so I got a squared minus b squared format. So I can write 3x squared plus 4x into 3x squared minus 4x. So mathematically, whatever he has done is correct. It's not that mathematically it is wrong, but our aim is to fully factorize it, fully factorize the expression. Now, is this expression fully factorized? The answer is no. Why? Because here the highest power of x is 2. Here the highest power of x is 2. So obviously these terms need further factorization. So that's why, student, do not, as soon as you see a problem, don't directly jump into this. So that is the reason why I'm saying, first point, look into the common factor first. Your step one, just like a computer algorithm, should be, okay, I got a problem to fully factorize it. Step number one, what are the common terms that I can remove? Step number two, then you see that out of all the forms which we are studying, or the patterns we are studying, in which pattern it may fall. Okay, and you may also go through them just in the same sequence. That's the reason why I'm taking in that sequence. Now here, so what should I do? If there is some common term or common factor, I'll first use that. So what is the common factor here? It's x squared. So if I take x squared as common, it will be what? 9x squared minus 16, right? So if you see, this is now 9x squared minus 16. Now, this part is already x to the power 2, there is no plus minus. So even if I further factorize it, I'll just put it as x into x and nothing more than that. X into x, okay? So that's why writing x into x or x squared are equally good or bad. Now, here if you see, so now let me use a curly braces because I will use other brackets, okay? So 9x squared is nothing but square of 3x minus this is square of 4. Okay. So obviously now this is a square minus b square format. So I can write x squared into, this part is nothing but 3x plus 4 into 3x minus 4, right? So if I remove the curly braces, now this is what is the answer. X squared into 3x plus 4 into 3x minus 4, that would be your answer. If you want, if you don't want to write x squared, you may still write x into x, even that is right. Or even if you write x squared, it's also correct. No issues with that. Okay, so that is how we should solve our problem. Step number one, look for common factors, remove the common factors, and then jump into the next step of solution. Okay, so if you want to write it down, just note it down, and then we'll jump to the next pattern. Okay, now, so we are done with our difference of square pattern. Let's go into the next pattern, and next two patterns will be perfect squares. Okay, so where we would try to see if our expression is in the perfect square format, right? So perfect square format means expression should be either as a square plus 2ab plus b square, and that one you may factorize at nothing but a plus b whole square. And if it is a square minus 2ab plus b square, then we'll factorize that as a minus b whole square. So if you see just in the previous problem also, one of my terms was x square. So I said that whether you write x square or x into x, it's equally good. In both the cases, you have fully factorized it. There's no issue. It's absolutely right. Similarly, while factorizing, you may write a plus b whole square, or you can two times you can write a plus b into a plus b, or a minus b into a minus b. That's up to your choice. Okay, so it doesn't really matter. Now let's see the expressions. Okay, so suppose you get this problem: x squared plus 4x plus 4, and in exam it has been asked to fully factorize, right, this one. Okay, so if you see here, okay, so the way we should, so sometimes in exam they may even give like this, right? So x squared plus 4 plus 4x. Okay, so try to do one thing, that the if you have any term which has got where x to the power is 0, so try to use that as one of the your major variables. Okay, so that is a square or b square, and the term where and this term, try to use it as a middle term. So this one can be rewritten as x squared plus 4x plus 4, or now I can write, so your x squared, this is nothing but square of x plus, this one is what, square of 2. Okay, now 2 I need 2ab, so 2a is nothing but your x, and b is nothing but your 2 here. So this is nothing but your 2 into 2 4, so 4x. So if you see, now this is correct. So I have expressed is that a square plus 2ab plus b square. So obviously if it is in this format, then I can write x plus 2 whole square, or if you want, you may write x plus 2 into x plus 2, and in bracket obviously you can write down, because a plus your a square plus 2ab plus b square is equal to a plus b whole square. So we know this basic formula in math. Okay, and as I just said you, it's a very good practice to write down these things, so that you remember this formula, and obviously as a life lesson you take it, that even if you do something else tomorrow in your life, you would get into the habit of writing the reason, right? So that always pays big dividends in life. Okay, let's see a couple of more practice problems, okay, on this, and with that we will take a logical ending of our today's session. So we'll see two more practice problems. So next one is x squared x squared minus 8x plus 16. So if you notice here, here also it's pretty easy. So I'll take this term. Okay. So is there any common term? Yeah, between these two, I can take x, and between these two, I can take 8. But obviously that doesn't help, because I said let's try to find out if there is a common term across everything. So there is no common factor across all the terms. So I would not use that step one, and I would directly jump into to see which format does it, or which pattern does it fall. So as I have three terms, so obviously it cannot be in my a square minus b square format. So no common term, it's not in a square minus b square format. So as there are three, let me see if it can fall in this format or this format. Okay, so quite easy. This is nothing but square of x plus square of 4 minus 2 into x into minus 4. So if you see middle term is minus 8x, that is 2 into minus 4, sorry, a squared plus b squared minus 2ab. So sorry, yeah, 4 squared, right? So a squared minus 2ab plus b squared. So that is nothing but x minus 4 whole square, or if you want, you may still write, or you may write x minus 4 into x minus 4, and you may write the reason that a square plus 2ab plus b square equals to a plus b. Sorry, it's minus. So we'll say a square minus 2ab plus b square is nothing but a minus b whole square. That's the reason. Okay, so a pretty simple problem. Okay, let's look into couple of more so that it becomes very natural to us and we can solve it, as soon as we see an expression. So the next problem is x squared minus 20x plus 100. This one, let me do it a little fast so that we understand. So this one is nothing but, okay, so step number one, there is no common term. See again, between these two, common term is x, between these two, common term is 10, but no common term across all the terms, right? Next thing, I have got three terms in the expression, so it cannot be in my a square minus b square format. So now let me see the next format. So it's x square plus 10 square minus 2 into x into 10. So if you see, this is minus 20x, so 2 into 10 into x, that is 20x minus, so I can say this is nothing but x minus 10 whole square, or x minus 10 into x minus 10. And again, because a square minus 2ab plus b square equal to a minus b whole square. And again, student, I reinstate that, or and let me say that it's very important to write this one. Even if, in your exam it's fine, I would encourage you to write the reasoning. Okay, let's go to the last problem for today. And with that, we will call it a day. Okay, so our last practice problem for today in factorization is minus 9x squared minus 9x squared plus 6x minus 1. Okay, so if you notice here, it's, is there any common term? Yes, there is a common factor, that is minus 1. And why I'm taking minus 1 is, if you see, it's minus 9x squared. So only once I have, this square of a term, this as a positive thing, then it becomes very easy for me. Or else I will end up getting irrational numbers, because I know minus one's root over is plus or minus I. So that would go into a different, branch of mathematics, and that is not in the scope of our class 9th and 10. So I will skip that. So what I'll do, I'll write minus 1. If I take minus 1 as common, then it becomes 9x squared minus 6x plus 1. Okay, now it becomes very simple. So minus 1 into, this one is 3x. Okay, so if I want to use a curly brace, so 3x whole square plus 1 square minus 2 into 3x into 1. So obviously this is a square minus 2 will be plus b square format. So that is nothing but minus 1 into, this is 3x, 3x, a square minus 2 plus b square, so 3x minus 1 whole square. And we can write, because a square minus 2ab plus b square equal to a minus b whole square. Now, what you can do, as there's a minus 1 here, you can take it inside and multiply, or you can leave it like this. But ideally, it's better to take it inside and multiply. So I can say, so 1 minus 3x whole square. Finished. You can write either like this, or you can write 1 minus 3x into 1 minus 3x. Okay. So here, if you see, I've just done a little bit of your beautification as per ideal mathematics. So if it is minus 1, you can take inside and you can just beautify it like this. Okay. So this will be your answer. Now, with this, we would do a logical pause of our today's class, and in the next class, we would see the next forms. That is, we would see how to factorize an expression with four terms, and we would see the most interesting one in factorization, which is famously known as middle term splitting. So, for those two things, we'll catch up soon in our next video. Until then, bye bye. Have a great time.